is how many kind of remote participants we're having, and you know, how easy or hard it is for them to participate. And then also new people, that's good for you to point out to us as well. People where maybe this is their first engagement at all with the IETF, that's something that we'd like to hear as well. So as soon as we have everything set up, which I think we just about do, we're going to get started. There's a clock up in front, and Dan's going to be operating that. There's a 3-minute countdown timer up here, so he'll restart it once you get up here, and it's going to start making a real annoying beep at you when you run out of time. So keep that in mind, and we are going to hold you to the 3 minutes. So we'll get through all these presentations.
display. So the Thunderbolt display will be available also for us.
Yep, I'll let you guys use it. All right, with no further ado, we'll get going. Hey, when you're presenting, I understand that people have a challenge hearing me, and I thought I was pretty loud. So when you're presenting, come up here and make sure you project. And folks in the back, if you can't hear, raise your hand or something, or I know that can be challenging, but let people know if you can't hear them, because it's not as much value if we can't hear. So for the most part, I'm going to try to stick to the order that's up here on this slide. So just to give you an idea of when you're presenting, you're going to come up one at a time, but hey, if you're the next person, be ready to go. So when your time comes, you can jump right in. So hey, we'll start with ACTN. You guys want to come on up and get us going? You want the Thunderbolt, right? Sorry, either adjust it or pull it out, whichever you want. It does adjust up and down. Yeah, do that.
Oh, yeah. It's more easier. Why is this not going? Is it coming? Not yet. Oh shit! What this I do? Backup. I have sent you the PPT, right? Just by the time I start. You have PPT, right? Correct. Oh. Good things we distributed our PPTs. Shut down computer. After? Good afternoon. I'm Jong Yun from SK Telecoms. We have a project is ACTN is called the abstraction and control of traffic engineering networks. So what is ACTN? As you maybe know, our team is know about that. But ACTN architecture is called the hierarchical SDN controllers concept. So it's our network is consists of very multiple domains and multiple vendors and multi layers. Is IP, optical transport network, some kind of the very difficult, complex network. So there is a domain. Each domain is controlled by their own controller. So the problem is how to orchestrate and manage it and control that controller and also network devices. So now we define the ACTN architecture as hierarchical controllers. So we want to solve this problem. And we have two projects. In one project, the IP project, and the other is optical project. So we participations so IP project team and optical project team is separately to make a process to solve define the project and solve the solve the result. And then so maybe the presentation is old, but the Jong Yun and Sati, this is new guys in the first time I attended the IETF in IP project. In optical project team is Sinyu and Boyoung is there is a Huawei and Beijing the university. Also in Japan companies also involved in this project in optical project. Yeah. So the first IP project is what we want the plan to solve is the multi-destination problem. So that means in case of gaming, it picked up the best game server. So among the multiple destination port, which is the best destination port, the based on the network conditions. So what we achieved is we defined the multi-destination API. The multi-destination APIs, we have information about domain name and service point and multiple destination point. And option is bandwidth, some kind of thing. We API, we can get the which destination point is best. So this is API, and the right side is ONOS is UI. So we can get the UI is which is the among the multi-destination point is one. Really? And in the optical part, so survivability analysis. That's optical part is we are using the Yang model for optical transport network model, topology model, and also one of the draft is the service model in the optical transport network. We are to do those Yang models, so we can, yeah. Yeah, oh, it's okay. We compressed, we can get the information. We API, by using the API, we can get analyze the network survivability in the optical transport network in real time. As you can see, the real time, you can get the information, and we calculate the resource uses, and now we can get which the optical link is failure. In the cases, we can get which services cannot be routed in this. Those the result. Okay. Sorry. Yeah, that's it.
Okay, thank you. Yeah, it's difficult to have to go first, but yeah, we are going to try to hold to time, and thank you so much for wrapping up quickly there. We appreciate it. The next one is on BGP. If you want to, you can pull it out.
Good afternoon, everyone. Here's the hackathon result for BGP, flow spec, and link status. I'm Zhen Qiangli from China Mobile. Our team members are from vendors, operators, and universities. At the end, our standpoint and what we did, finally the results validations. Our implementation is based on the honors. Honors had already supported some BGP-related features, such as the basic BGP link status and the basic BGP flow spec. So what did we did? Two things. The first one is to extend flow spec to support download to FIB features. Download to FIB, which means download some flow spec rules directly to the forwarding information base. Thus, the limited capacity of the hardware can be saved for the other flow spec rules. For the implementation in the honors, we introduced introduced a new wide community item and a new wide BGP community. And the southbound interface protocol is also updated to encode the new wide community with the flag atom. The second one is to extend a BGP link status to report the segment routing information to the controller. Thus, the controller can set up the end-to-end segment routing paths across multiple domains. For the implementation in honors, for this hackathon, we developed the link attribute TLVs, including the adjacency segment and the LAN adjacency segment. The command line interface is also added in honors to display the segment routing information. So here's the development environment. We install the owners on a laptop computer to act as the controller and get connected to the sandbox via the VPN connection. One of our team members also connects the owner's controller to his physical network in his university. Okay, wow. So we just skip the demonstration, and here's the reference. Okay, that's all. Thank you.
Okay, then we have a couple DNS related presentations. There's one that's a bit more general. Allison, I think you were going to do that one, and then there's one on smart card too. Here, I'll get it. Hold on a second.
Okay, so the DNS team, again, basically tackled DNS security and privacy enhancements and interoperability. And I've realized we should have a Kanban board because we have 21 people, multiple projects. We had multiple user stories. I think very successful. Multiple open source prototypes was the method of solution. I have two highlights and then lists of everything else. One highlight was the DNSSEC transparency project, which was NordUnet and NetNode folks. It's like certificate transparency, if you know that, but it takes care of posting the DS so that you can see what's happening in the worldwide DNSSEC deployment. That's the draft. The server was running as of 5 a.m. If you look at Linus Nordberg's tweet, you can see references to that server and how to send things to it. The client is talking, and this is Go and a DNS library from Meet Gibbons, and the server is Erlang wrapped around GetDNS. So a full protocol, brand new, up and running as a result of this hackathon. I'm not telling you what problems are being solved by these protocols, so come talk to us if you want to know more about our whole DNS ecosystem. But another one that we worked on was DNS 6.4, which is one of the necessary components for v6 only clients to talk to the v4 world. And it has some complications in engineering. There was a great talk by Jan Linkova from Google at RIPE 72. Willem Torup built this in GetDNS. So the client now works. If you want to, you'll soon be able to test this from the getdnsapi.net site. And we identified that there were multiple pretty high-profile DNSSEC sites that don't support v6, tisk, and so you can test against those and see that things work and see the details of how this is engineered. And here's a picture of this that I think we just don't have time to talk about, but it's very interesting engineering. You have to synthesize an address, do validation in a well-defined way, but that has not been done before. We were asked by Apple to work on this especially, so we're happy that we were able to accomplish this during this hackathon. There's a third highlight, sorry. Universal access is getting a lot of attention now, which is making sure that internationalized domain names are actually well addressed by all the code. And John Dickinson did reviews of GetDNS, and Andrew Sullivan gave us some solutions to some of our glitches, so he participated in the hackathon with us. And he also thought, in the interest of people's discussions of systemd, that you might like to know that systemd did not pass its tests very well. It needs quite a lot of work on IDNA. And talk to John Dickinson for more on that. Lots of participants. This is the list of us. We had a couple of people who are new to the hackathon participating this time, including a student from University of Paderborn, Mohammed Hassan Zeri, who worked with Paul Wouters on some IPsec support in DNS. And Joel Pura, who's also new. He's a consultant, works and lives in Berlin and joined the hackathon and will probably come to IETF as well. So that's good. This is the list of all the projects, not in a lot of detail. And there are more highlights which we won't present, but please grab our link if you want, our presentation if you want. And thank you very much for this opportunity.
I'm going to see if it works. I mean,
If not, you can send it to me and present
Well,
later.
okay, but
I'll
it's
come back to you.
all right, but it's already in the Snap in the what do you call it? GitHub. So I might just talk to it. You know. Hi. Apologize for this. It's really a geek laptop. Is there any chance that's going to come up? Probably not. All right, interest of time, this is already on the GitHub. I've never been able to get these kind of things to show up. It's under smart cards for DNSSEC.
Do you want to go next?
Huh?
You can go next. Send me your presentation and
All right.
I'll present from mine. So
I'll do mine in a
we're
minute.
We'll do it in a minute. Sorry, the I2RS one?
Yeah.
Do you need the Thunderbolt connector or is that a
Pardon?
VGA?
Yeah.
Which, do you need this?
No. I'm good to go. I just have to remember which side. Your computer. I just have to get the right one up. Oh, okay. This is I2S. We're in our progression of trying to get one initial I2S model up and going. We are working to get an implementation that was first created in the ConfD environment and where Yang models from Yang CLI Pro or from the ConfD. By the way, ConfD was generously part of the Cisco DevNet that's helping foster NetConf and RSConf. And we're trying to get to a Quagga daemon with a new Quagga daemon called R2SD that can be rolled into Quagga and hacking at the time. Okay, so that's what we tried to do. We had high hopes because we have so many ONS folks. We hope to get it up and running on a Ubuntu Linux and port it to ONS. Unfortunately, I wrote some code before IETF, but doing working group chairs sometimes delays coding. So that was struggle one. We got the builds working, but that's actually one of the lessons is our tool chains are struggling. We've got great work by Yang, we've got great work by ConfD, but there's all the little pieces that just don't work, and that seems to take hours. But we want to thank Carl, or it's C, is it Carl? Good, yeah, we want to thank Carl because he helped us out along with other people. So what did we learn? And again, the reason we're implementing it, this is R2S is one of its primarily prime protocol independent models. The other one has been the network topology, and that's already done in ODL. We're trying to take the approach of this is new work, ephemeral work that's going to be discussed in NetConf and NetMod this time. And so we wanted to be able to actually do a lot of coding and then release it to open source. So what did we learn about the IETF RIB model? Well, we said we had a very basic next-top model, and my answer after coding it is maybe we better think about basic and basic extended. It was quite a lot for the very basic model. IDs are good. transaction interface where you say, I want rib number 2, route 1, next hop 5 is a very effective way to do that. And one thing we had fun on was the debate on the top level instance or mount point for the Netcom folks caught us. Thanks to Carl for the aid on that. What next? Debug, get it working, send it out. I'm sorry, those last 5 points all went to the working group. What we learned, those all go right back to the draft authors. Those are all, we had the same, yes. And the last couple of things with notification went right back. This is code. It goes to tomorrow morning. So this is a direct one-on-one. Thank you for asking. Oh, just a minute. There's a team, about 5 people. That's really good because we had teams working, but this is our second ITF from a hackathon for this. So this hackathon work has gone between the hackathons. So this has become a group of friends. Okay.
So the next one is doing ILA, or you can come on up anyways. Okay, ILA.
Okay. Okay, so this is the ILA group, which stands for Identifier Locator Addressing. This is a story of code, implementation, test, and interoperability. So this is a team of fantastic people that worked with us. Half of them for FDIO, the group, and half of them other people joining us this time. So very quickly, ILA is basically something that is based on IPv6. It provides us host mobility in data center, but not only, and it works with node tunneling. You take an IPv6 address, you cut it in half. The first half is for locating the destination, and the second half is the identifier. I don't have more time to explain details. So what we did during this hackathon, we implemented basically ILA in VPP. VPP stands for Vector Packet Processor. We did that as a plugin. You can check out the code. It's being reviewed currently on Gerrit, gerrit.fd.io, and you can find more information on fd.io. So this is an implementation that we started from scratch. This is basically the story of our implementation. You can see how lots of code being written at the beginning. In about 5 hours, we got something working, like functional. Then we slept a little bit. We understood exactly what is ILA, which helped us remove a lot of code that was useless while adding more features, which is interesting. But that's usually how it works, I guess. These are our features. So we compare with the reference Linux implementation. In just 1-2 days, we got almost everything except the transport checksum neutrality. The transport checksum stuff. And IPv4 translation is currently being written. It's not tested yet, so it's not a full green cross yet. No, in terms of performances, VPP is really good. It's a virtual router running as a software. It's based on DPDK, and our implementation during this hackathon, completely made during this hackathon, obtained 8 million packets per second on one direction and 4 million packets per second forwarding in the other direction, and that is all on a single core. With VPP, it scales with as many cores and interfaces as you have. We also did, I mean, these gentlemen here, Tom and Maciek, did an interoperability between our implementation and the Linux implementation. It works. It is interoperable. And now I guess I'm almost out of time. The implementation feedback for NVO3, because it's important as well. I never put a step in this NVO3 working group. I had never read ILA before, so I can say that ILA works. It's fast. It's quite easy to implement. I would suggest some improvement to the draft, like for the implementation-wise, some help would be helpful. But Tom is a nice guy. Hey, do I get a bonus for that?
Okay, the IoT one. Do you guys need, you have an adapter? Okay.
All right, so we were the team EAP Noob, and what is EAP Noob? It's a EAP authentication method that utilizes an out-of-band channel. It can be used to bootstrap IoT devices, smart IoT appliances such as wireless displays, wireless cameras. Here we look at one example, this display, and you power on the display. The display shows a QR code. And when you, it runs the EAP method partially in band, and then shows this dynamic QR code. The user scans this QR code, and just by doing this step, he gets two things. So first, he gets the wireless connectivity, so it performs this network access authentication, but it also associates the IoT device with the AAA server in the cloud, from where you can eventually manage the device. So here is some screenshots from our implementation. So this is a device showing like what SSID it's connecting to, and this QR code is just an example. You could think of other out-of-band channels such as audio as well. So when you scan the QR code, you get pointed to a page. You log in if you were not already logged in. And then you see your device in the cloud interface from where you can manage it. So remember, you get two benefits. You connect the IoT device to the cloud, but at the same time, you also get network access authentication done. And at the hackathon, we spent quite a lot of time ironing out the feature requests, some of the remaining feature requests, such as roaming, support for roaming if the device is roaming. We also spent a lot of time experimenting. So we had some parts of the implementation, but we spent the most of the time at the hackathon, like fixing stuff and trying out some of the other features, like getting free radios to proxy. So if I go back, so here you see a local AAA and a remote AAA in the cloud. So getting that to proxy properly. And yeah, QR code was one example. We also tried to get it working with audio, and I guess Alex will talk about it.
Yeah, I joined the group just armed with a Pi and Wi-Fi, so I wanted to test out their implementation. The only thing with limited resources and cabling I could figure out was trying to do audio for another out-of-band channel. I got it compiled for Pi, and I used a pre-built modem software that does frequency shift keying and does the communication. Got that working back into to their cloud, and some future work. There's a JavaScript implementation someone made for demodulating it. I think that'd be interesting to maybe do a web-based authentication that way as well.
So I'll just finish with we had some first-time attendees in our team. We were around 5 people, and we plan to release the code, like clean up and release the code next month, or hopefully by the end of this month, if possible. Thanks.
All right, NetVC. Are the NetVC folks here? Yep, great.
Right. So we did IETF. So, oops. Yes. We're at the NetVC group over there. What we did is we had this problem that showed up recently, which is we have a deringing filter. The deringing was broken on the chroma planes. We added a new video that actually showed this effect. It was like, it looks all great until you see PSNR, and we made it 15% worse. That was bad. So, Alyssa Cooper worked on a solution, which was just simply disable deringing on chroma planes. So we wrote the patch, submitted it to our magical testing tool, and it is still in the queue. We had a second problem. We have too many things queued. We have 20 hours worth of jobs queued. So then that's what I started working on, is I was like, we need to fix this somehow. So the problem was, the solution to this problem is run everything in parallel. And I got down the crazy dependency chain of that. So I ran some in parallel. Then I had a problem. In my testing thing, we only have one binary compiled, uploaded per server. So I needed to upload potential multiple different things per server, which I implemented. And then I needed to basically actually compile multiple and save all the binaries, because I don't know which one I'm uploading to a server each time, because I'm running many jobs. So I changed everything to store the compiled binaries in our database, and that is as far as I got. So I don't actually run them in parallel yet, but I've gotten closer. So that's all the stuff we worked on. Did I fast it so far? Yeah.
I'll not try to attach. F5. Okay. Yeah. Why is it? Somebody can do it. I found a new one. My PC has given up. Use the PC. Yeah. Yeah, hi. Sorry about that. So this is about PCE, PC-based central controller. I'm Dhruv. And so what we were trying to do is, we know that any SDN controller, any central controller, path computation is the central function, and it is the heart of any central control. You need to compute path at the central location, and that's what IETF PC does. And we have a PCEP protocol for it as well. So what we have been working on is, what if we use the same protocol and same logic also to control all the devices in our network and program those devices with the label forwarding instructions using the same IETF protocol, that is our PCEP. And does it work? Does it have any issues? What are the new things that we need to worry about when we apply a protocol that has been used usually for a request reply, or now with the stateful PCE to control the head nodes? But instead of controlling the head nodes, you try to control all the nodes along the path like an SDN controller, but using the PCEP protocol. So we have this PCE as a central controller being discussed in the traffic engineering TEAS working group, and it's up for working group adoption. And we also have a PCEP extension for it. So this is what we came with. And we had participations, some are new, Andrea and Satish, and we also had remote participation from 3 people who attended. There's a link here in case people want to see this working. So what did we do for the hackathon? When we use PCEP for distributing label, we have LabelDB at the central controller. You have deep label database on your device. You need to make sure they remain synchronized. If the session, PCEP session flaps, we don't want to end up syncing everything again and making sure that the paths which were already established have any impact. So what we do is we maintain a database version, and if the session flaps, database version doesn't change, you don't have to do the full sync. You can avoid syncing. So that is, we have a draft. So this is the draft we actually implemented, and we checked on Wireshark, the number of messages being exchanged, and see what is the benefit that we are getting. When the PCEP session flaps and you use a protocol from central controller to the device, you need to make sure it works fine. The second thing that we did was, if you're using this in SDN controller environment, you have to make sure that the security works well. So using PCEP over TLS, so we implemented this protocol. This is a working testing is still going on. But one thing that we decided was that right now it's in experimental track. We wanted to push it to standards track. We see that its value, we have implemented it. So we want to take this to the working group and request that can we move this to standards track. So this is the Wireshark output with the number of messages. And what we used was Huawei Sandbox. That's the topology. The other side, you see the owner's display. And that's the YouTube link as well. Thank you. Any questions?
It's Alyssa. She's right. Hopefully. I can't tell you why. Let me just try. Actually, one more second. There we go. Okay. Sorry. That wasn't that fun. So we talked about TLS 1.3 last time, so you probably sounds familiar. New version of TLS, supposed to be faster, zero-run trip, etc. I won't belabor the point. We had a few stacks last time. Now we have 7 working stacks. Three of these are intended to go into production environments, namely NSS, Boring SSL, those power Firefox and Chrome respectively, and TLS Tris, which is Cloudflare's. And there are a bunch that are either BOGO, which is Google's testing one that exploits a lot of problems people find in their stacks, and then 2 verifiable implementations from Microsoft and INRIA. We also have 2 in progress stacks from Facebook and ARM. And a pile of servers which you could go and test yourself if you had your own TLS 1.3 implementation. Some of this we had coming in, a lot of it we did here. What we really did here, though, was this, which is the testing matrix. I don't know why that's yellow and not green, but what you're seeing, everything that's yellow there is interoperable implementations. So we have a few places that are known busted, but they're pretty small issues that we know how to fix. But mostly we have n-squared interop. And just for fun, this is TLS 1.3 in Firefox talking to Boring SSL on a server that one of the Google guys put up. Thank you.
All right, so what I want to show here, these are the results of the Yang tables, the 2 tables over there. So why do we do this? I mean, in the world of data model-driven management, what we start from is data models. From there, we have tools to generate code. We have tools to generate the CLI. We have code to generate like the documentation. So we've been focusing on tooling. It's not like the best great ideas you will discover here, but somehow the tool chain is very important. Your automation is as good as your tool chain. That's what we've been focusing on, and 2 full tables there. Now, the first one we did, and it was entirely done during the hackathon and multiple hackathons in the past, this is the Yang Validator. It's a website. You can just go there, put your draft. It's going to tell you if it validates any Yang modules in there. We extract the Yang modules, and then from there, we just compile it. And what Carl did today and yesterday is to add a new compiler. So now we've got 2 compiler results in there, right, to give more information to the people developing Yang modules. What Carl worked also on is a catalog of all the Yang models. If you look at the Yang models industry, we've got about 1,000 of them, different SDOs, etc. So we're working on a catalog to put all these Yang models in with the different attributes from the different SDOs. And Reshad is working on the new front end for querying this. Now, when I mentioned having a new compiler, that's also what I have on my website. So what I've been doing is a lot of scripts so that every single morning I wake up and I look at the diff of the day before, comparing all the IETF drafts, and I'm just sending emails to the author, your Yang modules don't compile. What I've been adding is yet another compiler there. So obviously we discovered a couple of issues, but if you look there on the right-hand side, this one is fitting XPath. It's a typical Yang module stuff, but in XPath, well, it was not checked with the previous compiler. Conclusion, the number of success Yang modules that pass compilation just failed. It fails, but it's good news because now we're going to produce better quality. We've been working on tooling as well, on Yang improvement with William coming from the BBF just for this. We've been solving issue on extracting Yang models with Vinod and comparing 2 extraction tools with Harry. Now, the Yang annotation is something that was done in order to better develop code. If you would be able to just say, it's not simply a list, but it's a queue, for example. And if I could annotate this directly into Yang, then it would be easier to produce code. And that's it for me. I've got 2
set of slides now for some more projects in Yang. Thank you. So Vladimir, you're next.
Hi. The main goal today was to get Debian repository online, so one can use apt-get install and apt-get source to get the complete toolchain for Yang. And this is a project using the wonderful open source BSD licensed Yuma that was available in 2012, and it's stabilizing it as much as possible. It's good enough to run on our commercially available switches. So that's now available online as a Debian repository, and this stays as goal 0. So the next step will be contacting the Debian people and trying to make it part of the next mainstream distribution. So this is a very good initiative, and it's been successful during those 2 days. And if anyone is interested, you can check the details there. That's about it. Yeah, and this is like what you need to do to get a complete netconf Yang toolchain. And if you do that, you can, for example, connect to this Ubuntu phone, which is running the same distribution, and you can see what you can do with it. It contains all the Yang models there, and it will tap complete all your wishes. So it's a cool way to get started. It's an open source netconf Yang. Yeah.
Oh, okay. For you.
Hello, my name is Qin Wu. I want to introduce this results regarding the model catalog. Actually, this is part of the Yang work. Actually, model catalog log actually we motivated by the OpenConfig model draft, and the reason we do this kind of work because today we have large number of the Yang model proposing not only in IETF but also in other SDO. So we need to figure out how this model relate to each other, which one model may depend on other model. So we come up with this kind of model catalog information. This is basic information we can extract from this Yang model. We can figure out how this kind of catalog information can help us to link this Yang model together. So we actually we extract the Yang the catalog information from the Yang model, and we figure out how to virtualize on this model catalog information. So we work with Carl on this project, and for the model catalog we started from the last Hackathon meeting, and we write this code, and but we think there's a lot of bug because we try to come up with some existing our own algorithm to identify some key elements, but we think maybe more useful. We actually try to reuse the existing Pingyang plugin. So we actually integrate this model catalog into this Pingyang plugin, and we can run the Pingyang tools. We can get the model catalog information automatically, and further we go a little step further. We actually want to visualize these kind of results. So we use the Web RESTful API and to display the model catalog information in different format. We can support the JSON format, and we can also support the XML format. And so for this kind of application, we have this kind of framework we set up. We allow the client to communicate with the servers. So we actually adopt the HTTP framework. We can map the HTTP method to the operation on different resources. Also, we use JavaScript and to allow interaction between the client and server. And so I want to show a little bit of demo so our demo is actually comprise two parts. The first is okay. So the user interface is quite similar to the YARN model extract and validator. So we try to reuse this kind of code, and we can load a list of YARN file, and we can actually click the catalog button, and we can get the catalog information in different format. So we can output this catalog information in both XML format and JSON format. Also, we can extract the catalog information based on RFC number or draft name. So that's the results we got. Yeah, thank you. Yeah.
Okay, hello, my name is Rasis Alsabo, and I'm here for the sysrepo project. Sysrepo basically is a new open source netconf Yang framework for any Unix, Linux applications. So basically what we are aiming is to provide the API for any open source applications that want to be managed remotely via netconf using the Yang. How we do that? We basically consist of two core components. One is the NetOPR2 netconf server, and the second one is the sysrepo data store. The sysrepo data store is Yang based. That means that if you have an application which wants to be managed via netconf, you just write the Yang model, install the Yang model into the data store, and instead of loading your configuration from some configuration files, you would load the configuration from the sysrepo data store. And just by doing that, you are automatically manageable via netconf remotely, because sysrepo is integrated together with the NetOPR2 server, which allows you the remote management. Okay. What were our hackathon achievements? We had two guys from IRC Kia DHCP server team who implemented plugin for sysrepo. So now they are able to manage some parts of their configuration via netconf. Another goal was to enable some remote management of Raspberry Pi via netconf. And we are now able to manage some simple relay switch connected to Raspberry Pi and temperature sensor connected to Raspberry Pi via netconf. Another goal was to write a plugin for IETF system Yang model. And what we managed to do during the hackathon is to is that we are now able to manage host name, read date and time, and platform data details via netconf, and execute RPCs for rebooting and shutdowning your host. And the most important hackathon achievement for me is that we gained feedback also from other teams sitting around here who are interested in Yank and netconf management. Okay, and this is a photo of our Raspberry Pi where we have a temperature sensor connected and a relay connected to it. And on that screen, which is behind the Pi or above the Pi, you can see the response to GET request to netconf server, where the Raspberry Pi returned the current temperature gained from that temperature sensor connected to it. So that's all. Thank you.
Good afternoon, everybody. I'm going to explain what we did to improve the performance in the establishment connection for the web partition point. Okay. So our goals for the hackathon were support ECDSA in the Currento media server, which was mandatory few months ago, and then verify the DTLS handshake with Chrome, Firefox, and Currento. Okay, and then we wanted to do a profiling to measure the improvement comparing RSA versus ECDSA. So for the implementation, we use libSSL. We had to generate the elliptic curve private key. We have to get the parameters from the elliptic curve group. And we also had to generate the self-signed certificate. We, moreover, added a configuration in the web partition point to choose between RSA and ECDSA. In the verification phase, we come across some problems because we missed this line to configure properly the OpenSSL. And thanks to David Benjamin's help, we could fix it. So thanks, David. Then, after that configuration, it worked fine. We interop with Chrome, Firefox, and Currento. Then we wanted to measure the improvement because for our team it's quite important the improvement in the systems. Not only that it works, but also that it works in an efficient way. Okay, so we thought about apply a basic profiling based on time. It could be indicative for people, but for comparative it's not so good because it depends on the CPU load, in the logs, and the number of CPU switching, and so on. So we decided to apply profiling to count the number of CPU cycles per function call. For that, we use a call-grading tool. That is, it helps us to measure this kind of profile. Here in this table, you all can see the results. For example, for the key generation, we can see that we need 420 million of CPU cycles. But for ECDSA, we only need 200,500 of cycles. So the improvement here, the improvement here is about 1,600 times. On the other hand, we have the improvement in the sign phase, where we can see that For RSA, we need almost 13 millions of cycles. And for ECDSA, we need 400,000 of cycles. So the improvement here is about 32 times. It's a good improvement thanks to ECDSA. And we also wanted to compare this improvement with the other WebRTC stack. For that, we compare the safe cycles in the Dieter's handshake with the cycles needed to encrypt the RTP packets. In this table, you can see that for encrypt an audio packet, we need 9,000 cycles, and for video, 22,000 cycles. Interpreting this table, we can say that with the cycles saved in the detailed handshake, we could encrypt 900 seconds of audio or 300 seconds of video. That is quite important. Okay. And just for finishing, we have to land in the current media server. For that, we have to pass the code review. We have to verify this in our integration, in our continuous integration system, and we want to contribute this to the GStreamer community in the detailed encoder and decoder elements that are used also for Open WebRTC of Ericsson. So that's all. Thank you very much.
Okay, so hello everyone. Today we really wanted to focus on service function chaining and how do we scale within a specific service chain, because of course everything related to service function chaining gets into the problem of how do we scale the different rendered service paths when the traffic goes up. So of course we could multiply the number of rendered service passes, but for the configuration perspective, for the classifier, how do we manage this? So another way of configuring and managing the traffic getting up or down within the data center is to implement the load balancing within the render service path. But with this, how do we handle the different cases when we just want to scale down or scale up? One way of answering to this question is to say, okay, the client will just restart the connection, but in some cases, it's not acceptable. So, what we wanted to do for the hackathon, we wanted to get more into VPP, and so we wanted to create a floatable plugin with a load balancer plugin. So very simple ones, but still they get into VPP. And in order to test it, what we wanted also to do was to create a specific integration within Mininets. So now let's switch to the demo. Okay, so we already have standard VPP running with the new plugins. So creating the new Mininet topology. And now, what do we have? So here I do have a very simple topology. So one client, two different servers connected to the same switch, and with the I will enable the load balancing between the two different servers. And so on the first one, on the first try, when I hit the And yes, it works. It's always better when the demo works. So as we can see here, on the first attempt of the curl on the same IP address, I'm getting the first, which is red here, and I'm hitting on the second server, so the green server here. So those were a bit different slides. So what did we achieve? We achieved, of course, the minimum integration, as you saw. We also integrated and created the filter within VPP. And well, what's next? Today we do not support yet NSH. That's the next step. And of course, test, optimize, and finally put it into Gerrit for the VPP project. Thank you.
That's good. All right, thank you. So my work was on using smart cards instead of HSMs in DNSSEC, and that's my particular specialty. I spent a lot of time, talking to people and explaining them how to deploy DNSSEC. And one of the problems is with HSMs, hardware security modules. They're very expensive devices, and they take a while. So why don't we just use smart cards? Should work. There's a common standard among smart cards. You can read that as well as I can, easily replaceable, whatever. Smart cards have similar security environments as HSM, so this is sometimes helpful for implementations. There's some smart cards out there, in particular, that are very, very useful here. There's something called Card Connect. They have a smart card HSM. It actually has a lot of the qualities of HSM. In other words, allowing you to back up the contents inside the HSM from one smart card to another. In particular, a lot of these cards now support ECDSA, elliptic. Cool stuff, okay? So why don't we just use this? There are a couple of, well, here's some history here, so this is maybe a good thing to do. It's not new to try to use smart cards as HSMs. Jacob Schlieder, many years ago, started with this. There have been patches to bind that I've had out there for a while. A friend of mine, Luis Espinoza from NICCR, does this. A couple CCTLDs actually use smart cards for exactly this purpose. But they have to continually patch bind and other software to make this stuff work. I know that there's some softwares that actually do support this stuff natively, but bind does not, and that's one of the most popular ones. So the goal of this, my hackathon thing, was simply to produce some way to just make this work, so that I could take a stock copy of bind, not have to go in there and do brain surgery, and just use some standard smart cards off the shelf. There's a lot of, the nice thing about this is a whole set of documentation already out there. There's key ceremony scripts, there's DPS, the full documentation is there. I do this as a regular thing and go around teaching this stuff. So it's something that you can leverage right away if you're doing a DNSSEC deployment. Basically what I do in my little piece of code, and it's uploaded in the GitHub in here, is that red part. Basically, you have bind talking native PKCS11, so it wants to see a full suite of PKCS11 support. But what I do is I supply and give it whatever what is missing from, say, a standard smart card. Smart cards have limited functionality compared to an HSM. So it's a driver, I'm just trying to solve a problem here. Here's some code. Yes, I'm doing elliptic. This is what makes it interesting. The smart cards do support elliptic, and I'm just going to cut to the chase. DNSSEC guys here know what DNSSEC sign zone is, but you can see at the very bottom few lines there, algorithm, ECDSA 256, it's signed, zone sign. So it works with smart cards. That's really it. And then there's the output of the signed zone. It actually did work. Again, for you DNS experts here, you see the 13 there showing what type of encryption technique is there. And of course, there's much more. All this is on the GitHub site for the class. And that's it. Thank you.
So I believe that's it. We made it through all the presentations. Anyone I skipped or wasn't here when we were collecting names? Okay, great. Well, then we'll let our judges go off and deliberate a bit. And a couple other things. So I did mention before we were going to have a contest for the photo contest, putting things to Twitter. And don't know if she's here, but this was the one we selected as our winner. Terrell, are you here? If not, we will get you afterwards. She's much better with a camera than I am. I had a lot more ones that I put up there, but I think she captured it really well with the signs and all that. So round of applause for Terrell for winning our Twitter contest. And so another thing, while have all you here, one thing I always like to do is see what we can do better for next time. We tried a few different things, including I want to remind you that we will have some space set aside in the IETF lounge where we'll have a corner of that kind of signed off so that you can go and hang out there, just to make it a little bit easier for people to find each other, to congregate, to continue to work on code. It doesn't need to be specifically the project that you worked on here, but it certainly could be. Has anyone registered and figured out where the IETF lounge is? Because people have asked me and I haven't been able to tell them. Anyone know where the lounge is? Just down the hall? This? Okay. So if you go in there, I'm pretty sure we'll have a sign. I think we're going to take the sign that's outside the door here for the hackathon, and we'll put it there. Another thing we tried, so these posters, which were featured nicely in the photo and also now are around the room, we skipped all the presentations at the beginning and we used the posters. Just a show of hands, how many people think that was a good idea and that we should continue to do that type of format? All right, how many people thought it was a bad idea and really, missed not being able to hear all those presentations at the beginning? Okay, I think I know what we're doing at the next hackathon. Other things, any feedback people are willing to give, things they'd like to see different at the next one. Because, we're obviously trying to change things as we get more people participating, which is fantastic, and we absolutely want that. We need to think about what to do to make it the best use of everyone's time. So give that some thought. I'm going to be around all week. Yes. More coffee. Yeah. Yeah, I did get a Diet Coke. We need more Diet Coke. The ratio was off. Better Coke. Okay, maybe we better not touch that one. Better coffee, though, we can continue to work on. But seriously, think about it and let me know, because the idea about the posters and that wasn't my idea. That came from someone else, and I think it really worked out very, very well. So things like that, those of you who are participating, you may have a better idea of what we need to do to make this more useful for you. So let me know. And Yi, did you want to come and say a few words? So for those of you who didn't know, Huawei has been sponsoring the hackathon, not just this one, but the previous one and the next one. And so a big round of applause to Yi for that, helping make that happen. Thank you. Turn it over to you.
I was, first of all, my name is Yi Zhao, and I work for Huawei US R&D Center back to the Plano, Texas. I was asked by the judge, say, keep talking, entertain the audience so that they can have time because this time we have about 15 or so the projects needed to review. So I bet that they need more time on that. I try my best. So first of all, I think we are very happy that have the opportunities to host and sponsor the Hackathon, and from the first one, the first one this year, and the second one this time. And by the way, this time I see pretty much double the people and double the projects. So that means location and the weather really help. So, and also we are hosted the Hackathon, the third Hackathon this year in Seoul, Korea. Thank you. We think the open source is very important. The code open source is very important. Is especially these days you see the open source there. I mean, growing the influence not only is traditional in the IT sector, is also getting to the communication industry. And also another thing we see is the how open source and the open standards can work together. This is a challenging one. Just for your information, because IETF is doing like a hackathons, some other organization is also doing some similar hackathons. But meanwhile, some very traditional organization, for example, IEEE, they are investigating the possibility how they can embrace the open source. And they are even thought about whether open source can become the part of the novelty standards. So of course, the most challenging part, how you take care of those IPR policy. So we do see like an open source, I mean, on the standard side, open source can help you to speed up a standard, can help you to get your standards adapted to the market. But on the other side, because we talk with the open source community, OpenStack, Linux Foundation, they gradually see the needs for standards as well. Of course, they don't like the term standards. They say spec. Well, eventually this is standards, right? They talk about the specification, especially in the past, I would say about a year, they see the needs for the specification or standards for the interoperability. Take an example, OpenStack is very popular today. There's over 100 different models. And when the customer tries to come up with a solution, and then they run into the interoperability issue. So you need a spec or standards for those interoperability. So you see that both two sides have those needs. So there's a huge potential in how those two open standard and open source can work together. So I think for the IETF, we started the IETF study, the hackathon from last year, right? And this is the second year. So I would suggest that IETF can look more further. And I mean, hackathon is just hackathon created code, right? So more further how we can do and then put more efforts to embrace those open source. And as I say, this is a challenge, how those two can work together. But there must be some way moving forward. Looks like they're still working, and I have to still continue to talk. The other thing is I want to say is I want to thank the others, the supporter like a Cisco DevNet supporting, and also some other stuff of supporting for this the event. And I'm hearing that we need more Diet Coke and anything else, because I know this group is like talking about the size of a cookie or those kind of things. So anything, because there's a second, the hackathon, we hosted and sponsored. Anything you think can be improved, let Charles, let us, let Barry know. We have one more hackathon host we'll be hosting in Seoul. And also I take this opportunity as to ask more community support for the next year's hackathon. And IETF is looking for the host and the sponsor for next year hackathon. So anyone have interest, and please talk to us. They're still working on it. Or open mic right now. Any question? Question, comments? It's quite good. And yeah. Charles, do you have anything on the top? Okay, thank you.
Yes, I think that raised a very good point that, you know, I think I want to thank all of you too for showing up and making the hackathon a success within the IETF, because obviously it's working quite well for us, and I think I've heard a lot of good things within the IETF about it, but the fact that other organizations are kind of looking and going, oh, wow, you know, there's something to that. Maybe we should look at doing something within our own organization, be it some open source foundation or some other kind of standards body. This idea of getting people together and having them, you know, work on code together that has something to do with the projects they're defining or the standards they're working on has really been catching on. And I think with the IETF, you know, we set a good model that now people are trying to replicate or you know, adapt to their own business, their own environment. So really helping change the way a lot of people work. So thank you to that. And so the way this is going to work is our judges are figuring out a set of winners. And for those of you who haven't attended before, the way we do that is we have a bunch of prizes up here that have been generously donated. And so they'll announce all the winners, and then afterwards they'll go through and kind of in the order that they predetermined, they'll have you come up and pick a gift. And we have enough for all the winners to get a gift, and we should have some extras too. So once we're done with the winners, whatever's left over, other people are welcome to take, kind of first come, first serve. Please don't take more than one thing when we get to that stage to leave stuff for other people to take. And then again, I encourage you to think about bits and bytes. And Barry, who's one of our judges here, he'll be running that for us. So at least the hackathon participation there. So if you haven't already seen him and let him know that you want to demonstrate something, let him know. That would be great. And one other logistical reminder that I wanted to make sure I mentioned, there is the newcomers event. I forget exactly what they call it, but kind of where the newcomers can go and meet the chairs and the ADs and other people within the IETF, and that's from 4 to 5. So if you're new to the IETF, really encourage you to attend that. And then just make sure that if there's anything you leave in this room, you know, if you want to run off and go do that, I think that's great. We have the room until 6, but so make sure you come get anything that you need out of this room by 6, because at 6 p.m. they're going to come and completely clear it and reconfigure it and set it up to do something else. So keep that in mind and manage your time accordingly. And judges, do you have news for us?
We have news. So first, I just want to say we're really thrilled with all of the work that's been done here. That's the large number of people who have been working on this and the great progress that everybody's made. We really had a tough time picking things out and deciding how to award these lovely prizes that we have up here. Got a number of, I always wonder, is it mice or mouses? And some lenses for your cell phone camera and a bunch of other things like that. The deal is come up as your group is called and pick what you want, and whatever you leave is left for the next group. So best overall project we gave to the ILA people. And it really was a tough choice, but they got it. So come get your things. And while they're having a frenzy at the table, we'll give the next thing, which I think is a very important piece of this, probably to me one of the most important pieces, is feedback to the working group. What your work here fed back into the documents and the work that the protocols you're working on are doing. And for that, we gave to 2 groups, the PCE group and the I2RS group. So now we're doing photo ops. I'll pause for that. Okay, PCE and I2RS head up, please. PCE and I2RS. Come get your loot. Go on. Okay, while they're collecting, the Yang Gang, I think I said that last time too, for the work that is the most significant for the IETF to keep everything organized and get our network management stuff arranged right. We gave that as most important work to the IETF overall, to the Yang group, the three Yang projects together. So come on up and get ready to get your stuff.
Yep, come on over, and once you got your box. So we learned that another improvement for next time is we'll have to let folks study the prizes ahead of time so they have some idea of what they're playing for when they come up here.
Indeed. So another very important thing about what we're doing at the hackathon is interoperability testing for the technologies that are about to roll out to the internet and are going to make significant changes to the internet, need to do it without disruption. The TLS 1.3 folks did a really good job of that. So come up and get your stuff for... But we should have made a secure pipe for them to come up in. And the next thing we looked at was how much progress did you make in your goals during the hackathon period? And we thought that the BGP group and the EAP noob group did a really good job of that. So for best progress during the hackathon, BGP and EAP noob.
He's like really working. He's like really having trouble figuring.
Three in one photo.
Yes, that would be appropriate. We've got one more, but I'm going to let the crowd thin first. Okay, for putting together the best ecosystem with the different pieces of your project and making progress on the entire ecosystem, we have the DNS crowd. So many different pieces of the puzzle at once. So when the table clears, come on up and pick your stuff. And that's it for specific prizes. When everybody's done with picking up what they like, anyone feel free to come up and take some of what's left. The sponsors do not want to bring it home. And again, thank you all for coming and participating, and come in Seoul.
Yeah, you should be here as well.